Hey there, students. So in this clip, we're going to be going over some example problems on conics. This is part 2 of the review session. So let's go ahead and take a look at some problems. All right, so for question number 1, we have the conic equation of a conic in general form, and we're going to try and associate it with one of these graphs. Okay, so we have x squared plus 6y squared minus 10x minus 11 equals 0. So what we're going to do is basically complete the square in order to put it in standard form, and then we can associate it with one of these graphs. Okay, so what we're going to do is we're going to put the x's together. So we have x squared minus 10x, and then the y together. 6y squared is by itself. This number right here, this constant, is neither has an x nor y. So I'm going to move it to the other side. Okay, so just add 11 to both sides. So this is going to be equal to 11. All right, so what I'm going to do next is partition my variables down the center so I can stay organized when completing the square. All right, so if you look at the x, it looks prepared to complete the square. So all I just need to do is add b over 2 square. So for my x, my b is basically, b for my x is negative 10. So to complete the square here or create a perfect square trinomial, I'll just divide this b by 2, negative 5, and then I square it, and I get 25. All right? So here I'm going to have x squared minus 10x plus 25. Okay? So this is a perfect square trinomial by design. In the y situation, we can just factor out the 6 and express this as y minus 0 squared, because nothing's been added or subtracted here, so we can just express it like that, equals 11. Now, to preserve equality, since I added 25 to the left side of my equation, I need to do the same to the right side of my equation. So to compensate for this added 25, I need to add a 25 here. Okay? Now let's factor this. Using the factoring tree for perfect square trinomials, you take the square root of the first term and the last term, and then you bring down the middle sign, okay? If you do that, you're going to end up with x minus 5 quantity squared. All right, plus 6 times y minus 0 squared. 11 plus 25 is 36, okay? Now, I know that for the standard form of conics, let me write it down here. For the standard form of conics, we do not need any coefficients in front of the parentheses. Also, we like to have it equal to 1. So since it's equal to 36 and I want this equal to 1, I need to divide every single term by 36 in order to accomplish that. Okay, so whatever is here, you divide every term by that number. If it's other than 1, divide every term. Make sure that is in this form first before you do that. Okay, so divide this by 36, so it's equal to 1. Divide this by 36, and divide this by 36. All right, so that's going to leave us with x minus 5 quantity squared over 36 plus 6 goes into self once and it goes into 36 6 times, y minus 0 squared over 6 equals 1. Okay, now this clearly matches with option letter A. Okay, this is an ellipse. You're going to go side to side 6 units from the center, and then you're going to go up and down the square root of 6. So that's an ellipse right there. You can see this is a hyperbola. It's not because you have a minus here. This is inaccurate because you don't have the 6 next to the y squared, and this is inaccurate also because you're missing the 36. All right, so the correct answer is option A. Now let's take a look at number 2. This is a similar problem. We have x squared minus 8y squared minus 14x minus 15. Okay, this is a general form of the equation of a conic. We're gonna put this in standard form so we can associate it with the appropriate graph, all right? But before we even start, we can tell what the answer is. Well, I'm not gonna tell you. Let me do it first, and I'll tell you how to discern what the answer is. without doing any work. All right, so just to review the whole process of completing the square again, I'm going to put the x's next to each other. So x squared minus 14x. And then y to each other, we just have a one term with a y here. This is neither an x nor a y, so I'm going to move it to the other side by using the inverse operation, which is negative adding 15. So it's going to now be equal to 15. All right. Now we're going to split it down the center, and then we're going to create perfect square trinomials where applicable. We have two terms here, so we need to create a perfect square trinomial. So to do that, I just need a b for my x. The b for my x is negative 14, so I divide that by 2, which is negative 7, and then I square it, which is 49. All right. So to make a perfect square trinomial here, I add 49, 14x plus 49. And if you have only one term, which is a square in this case, we don't have to do any complete perfect square trinomial. All we just have to do is factor out the negative 8 and express y as y minus 0 quantity squared equals 15. Okay? But we added a 49 here, so to compensate for that, we need to also add a 49 to the right side of the equation to preserve equality. All right? Now we have a perfect square trinomial in the x area here, so we're going to use a factoring trick to factor this perfect square trinomial, which involves reading the first term and the last term and bringing down the middle sign. Okay, so that yields x minus 7 quantity squared. You read the first and the last, bring down the middle sign, minus 8y minus 0 squared equals, if you add this, you get 64. All right. Okay, so what we're going to do next, to write this in standard form, we always like it to be equal to 1, right? So it's equal to 64 here. To make this equal to 1, I need to divide every single term by 64. So divide that by 64, divide this by 64, and divide that by 64. All right, and then your answer is going to be x minus 7 squared over 64. 8 goes into itself once and goes into 64 8 times. So minus y minus 0 squared over 8. 64 over 64 is 1. Okay, so this matches with option letter D. So the shortcut I was going to tell you earlier was that if you notice that you have two squares, okay, you have two squares in the original equation. So if you have two squares, you automatically, so every problem has a square. But if you notice that the two squares has a minus in between them, so that tells you that it cannot be A, it cannot be A, and it cannot be B because the two squares have a plus in between them. But this is, so your option is either C or D. But if you look at this equation, this is the equation of a hyperbola, but this is a graph of a parabola, so this is wrong. So you can just determine that the answer is option letter D just using the elimination, because anytime you have two squares separated by a minus, it's always a hyperbola, not a parabola. Okay, so the answer is option letter D. All right, let's move along to question number 3. What conic is this? Now you notice that if you have two squares, it's either a hyperbola, an ellipse, or a circle. Okay, if you have one square, just only one square, it's automatically a parabola. Okay, in this problem we have two squares, x squared and a y squared, so eliminate parabola. It cannot be a parabola. All right, so next thing you want to look at is the coefficients, the sign in between them. Okay, if you have two square and a minus, okay, you have a minus between them. Minus between the squares is automatically a hyperbola. These two squares have a plus between them, so it cannot be a hyperbola. So the question is either an ellipse or a circle. So if the coefficients are dissimilar, not equal, then it's an ellipse. Well, the coefficients are equal, is a circle. Coefficients are denominator. Okay, coefficients are denominator and different as ellipse. That's what accounts for its eccentricity. But if the circle has equal coefficients or equal denominators for the factored squares, then it's a circle. The coefficient of x squared is 1. The coefficient of y squared is 1. The two squares have the same coefficient, so our answer is option C. It cannot be B. Alright? There goes your answer. Alright, let's take a look at question number 4. I'm going to use the same idea. We notice that we have two squares in this problem. So if we have two squares, we know it cannot be a parabola. Okay, it's either hyperbola, an ellipse, or circle. What makes it a hyperbola? If you have a minus between the squares. But let's look at this. Is 70, if I rewrite this problem, it's basically going to be 70x squared plus 40y squared, right? So the squares has a plus in between them. So it cannot be a hyperbola because hyperbola requires it to be a minus. Next thing we're going to look at is the coefficients. This coefficient and this coefficient are different. Remember, the coefficients are different is an ellipse because that's what makes it eccentric in one direction. But if the coefficients are the same, it is a circle. Coefficients are different, it cannot be circle. Your answer is option letter D, which is an ellipse. Okay? Alright, moving right along. Question number 5, we're to graph this conic. I'm going to write this in standard form, and then we're going to graph it, okay? So we have 3x squared plus 3y squared equals 75. Standard form, we like to write it equal to 1, so we'll divide everything by 75. Divide this by 75, divide that by 75, divide that by 75. Let me write the standard form of the equation of a conic for you so that you can see the reasoning behind it. It's basically x minus h squared. In this case, we have a plus between the squares, so x minus h squared over a squared plus y minus k squared over b squared equals 1. So I want to put it in this formulation so I can know what it is, okay? So dividing by 75, 3 goes into itself once, goes into 75 25 times. So you have x squared. Let's write it like this. Let's write it as, oh wait, let's just do that first. One step at a time so we don't get confused. X squared minus 25 over 25 plus, same story here. 3 goes into itself once, goes here 25. So y squared over 25. 75 over 75 is 1. So now I'm going to express this as x minus 0 squared over 25 plus y minus 0 squared over 25 equals 1. Since the denominators are the same, that means it's a circle. Okay, so the center is going to be 0, 0. All right, and what direction are we going to go? So direction, we're going to go square root of 25, which is 5, side to side. And then also 25 here, 5 side to side, 5 up and down. So you're going to go 5 in all directions, 5 units in all directions, which makes it a circle. So let's see which one matches with that. So it cannot be this because it's not centered at 0, 0, and it cannot be this either. The center has to be 0, 0 per our first remark here, which is that the center is 0, 0. Now, which one goes 5 units in all directions? This one goes 1, 2, 3, 4. This one goes 1, 2, 3, 4, 5. This is not the answer. The correct answer is option C. Okay? So there you have it. All right, moving right along. Another way to do this is another way you can do this problem. Let me show you. Is you just notice that the coefficients are the same. You can divide everything by 3, and then you have x squared plus y squared equals 25, and then you can write it as x minus 0 squared plus y minus 0 squared equals 25. And you can clearly see that this is a circle with center 0, 0, and the radius is the square root of 25, which is 5. And that's consistent with option letter C. Okay? So 2 different ways of doing question 5. All right, let's move along to question 6. It says, what is the standard form of the equation of a circle with radius 7 and center 0, 0? This is going to be a circle. So the standard form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. In this case, h is 0, k is 0, and r is 7. Okay, so let's plug all that in here. So we're going to have x minus 0 squared plus y minus 0 squared equals 7 squared. Simplifying that, it is simply x squared plus y squared equals 49. So the answer is option letter B. All right, moving right along. Question 7, we're going to graph this equation. I can use the trick I showed you earlier because you notice the coefficients are different. Okay, so we have 4x squared plus y squared equals 36. I want to make it equal to 1, so what I'll do is I'll divide everything by 36. Okay, divide this by 36, divide this by 36, and divide that by 36. So that yields 4 goes into itself once and goes into 36 9 times. So we have x squared over 9 plus y squared over 36 equals 1. Let's write it in standard form. We have x minus 0 squared over over 9 plus y minus 0 squared over 36 equals 1. From this, I can tell that my center is 0, 0. Okay? And if I want to look at the axis, direction of axis, if I take the square root of 9, I get 3. What direction do I go? X-axis goes side to side, so I'm going to go 3 units side to side. So I can stop there and look at this. Since there's a plus in the center and 2 squares, it cannot be a hyperbola. If it were a minus, then I'll know either this or this, right? So it's either one of these two. This tells me to go side to side 3 units. This goes 1, 2, 3, 1, 2, 3, 3 side to side. And this goes 1, 2, 3, 4, 5, 6, 6 side to side. This is wrong. The correct answer is option B. Because in this answer, when we take the square root of 36, it is 6 units up and down. Okay? We're not supposed to go 6 units side to side. So this is wrong. And you see this one, we're going 6 units up, 1, 2, 3, 4, 5, 6, and 6 units down. And this is exactly what we want. So the answer is option B. All right, moving along to question 8. We know that we have 2 squares and a minus. That automatically tells me that it cannot be an A or a B because when you have a minus, it's always a hyperbola. Another trick we can use is look under the x. We have 4. What do we do? What do we get if we take the square root of 4? We get 2, right? So the central box is going to be 2 units side to side, and the opening is going to be side to side also. So which of these hyperbolas has a vertex 2 units side to side from the center? Let's look at it. This one goes 1, 2, 1, 2, 2 units side to side. And this one goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 units side to side. So which is the correct answer? Clearly it is C, okay? Because this Y has 5 units up and down to create the other component of the central box. Okay, so this is the wrong answer. Correct answer is option C. Remember, in this problem, the center is 0, 0 because you do not have any number you're subtracting from your x or y, right? So x minus 0 squared minus y minus 0 squared over 25 equals 1. So the center is 0, 0. So there you have it. All right, moving right along. Question 9. It says which represents the graph below. So what we need, we don't have to do too much work here. We can just find the center and the direction in the x. So the center is 1, 2, 3, 4, 4, comma, negative 1. And we're going to go 1 to 2 units side to side, 2 units side to side. All right? So if I write this in standard form, I'm going to have x. You do the opposite of the x, which is minus 4 squared, over, since you're going 2 units side to side, you must square this, right? So over 4 minus y, the opposite of that, plus 1 squared. I don't really need to know anything else. This is sufficient for me to figure out what the answer is, okay? So let's see which one matches minus 4 and plus 1 is either, oh, actually, it's just this one. Just looking at the center alone, that tells us that this is the answer, because this is the only one with the correct center. Because the center here, you do the opposite, is 4, negative 1, and that's exactly what we want, so this is the answer. Okay, so the answer is D. All right, so for the last one, we're going to graph this conic 3x squared plus 3y squared equals 48. I want to write this in standard form, so I need to make this equal. Well, since these were the same, I can divide everything by 3, right? So, let's see. So I can divide everything by 3. Oh, okay. So divide everything by 3. We'll divide by 3, divide by 3, and divide by 3. So I'm going to have x squared plus y squared equals 16. This is called a circle. In standard form, it's going to be x minus 0 squared plus y minus 0 squared equals 16. So the center is going to be 0, 0. And my radius is going to be the square root of 16, which is 4. And that means I'm going to go 4 units to the right, left, down, and up. Okay? So graph the center. Go 4 units to the right, 1, 2, 3, 4. 4 units up, 1, 2, 3, 4. 4 units to the left, 1, 2, 3, 4. 4 units down, 1, 2, 3, 4. Okay? And then we can just graph our circle. So there goes the graph. Okay? So that's that. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here. More videos coming from mathcoachchef.com. Thanks again and have a wonderful day.